AI demand is going to lead us to fully sustainable energy.
Moore's law looks silly next to how fast these AI chips are evolving.
You take a typical computer, you have your chip, and then you have the memory, you have the connectivity or your network card all in different places. If you can put all that on the same board, it integrates, it makes it better, faster, cheaper.
Tesla could be humanity's brain in a way. Like they would do all, because they have so many different modalities that they can process and provide tokens for video, audio, text with Grok, et cetera, et cetera. So they're positioning themselves as one of humanity's brains that people can basically rent.
Okay, Jordan, so we're here today to talk about this incredible new partnership that Elon has announced with Samsung. Obviously, this has huge implications for AI, but you think a lot of the conversation out there that people are talking about with respect to this topic is pretty much bullshit. So set it up, tell us why.
You can say bullshit, because now YouTube has removed demonetization from the first 7 seconds if you curse, FYI. So thank you, YouTube.
Well,
it's
bullshit.
BS.
Bullshit wasn't the word I used, but red herrings from my perspective. A more level-headed view on that. But that's a punchy intro. So my view, like people were talking about, well, they can't do AI 6 for both inference and training because you can't do that on the same chip. And to me, I don't have in-depth knowledge of how chips are designed, etc. But currently, the A100s in the past, the H100s, the GB200s, they're all designed to be used for both inference and training. So I don't see why the AI6 would be AI6 chip wouldn't be any different. And now you could optimize chips for specific use cases, but to say that it can't be done or it doesn't make sense, well, the proof is in the pudding right now because all of NVIDIA's chips can do both of those. In fact, you can do both of those with like the GPU in your computer. That would be extremely inefficient, but you could still use the GPU in your computer for training and inference. So, like if you say, for instance, if they did want to optimize a little bit further within that, my understanding is the difference between a chip that's optimized for inference and a chip that's optimized for compute or training. Has to do with the amount of memory, the bandwidth, and processing power, the ratio between those two different things. So technically, my understanding is that Tesla, they could design a chip specifically for training and then just tweak it a little bit for inference, maybe just remove a little bit of memory off the board or something like that. But you may know more about this than I do. I'm curious about what your view is.
Well, yeah, I think that's a pretty good high level view of things. One of the big challenge in training versus one of the big challenges in training versus in inference is just loading up the data and keeping it close enough to the actual processing units to keep them fed so that they can just continue to crunch numbers at basically full speed. And it's really, really hard to do. And, nothing really achieves that feat of making sure that every processing unit, in an entire AI cluster is actually doing math every single clock cycle. That there's a lot of latency in getting that data right to the place where the math actually needs to happen for these, huge training clusters. And that's a much easier, I think, process to engineer when you're doing inference at the edge, especially if you got, like a small thing doing inference instead of, doing inference in a big system out in the cloud. One of the things that Samsung is working on, I'm sure that TSMC is doing this. I haven't done as much research, but is a process to actually make not just wafer scale chips, which is what like Dojo 1, they take 25 of the actual Dojo chips and they put them in a 5x5 arrangement on a big wafer. And they use the silicon of the wafer then to connect each chip to each other. And then they have, connections from off the chip then to the next chip over. And by putting all of those 25 chips on a single wafer, they really optimize the communication between all of those chips. And then your challenge is, okay, now how do you make sure that each chip can talk to the next chip over fast enough to where you can keep that data feeding through and flowing? And then it's always hard, you have to keep the data moving, and you have to have the memory that's close enough to the chips to where, you're not having to wait multiple clock cycles for the data to get from wherever it's stored to wherever you actually need to do the math. And so that's wafer scale. TSMC is the one who's doing that for Dojo 1, Dojo 2 as well, I think is planned with TSMC. But I think the panel thing is interesting because instead of doing single wafers, they're trying to figure out ways to do, and a wafer is a big circular thing, right? So you've got a 5x5 matrix of processing units so that's a square on a big circular die that then you have to cut off a whole bunch of in order to then make your nice square tile. The new process that people are working on and trying to get working well, and to be able to work with the more advanced manufacturing and packaging methods for these chips, are called panels. And those you can make much, much larger than a single wafer, and they are rectangular to begin with. And then what you're unlocking is you can have, way more chips all able to talk to one another seamlessly, without having to do the very difficult task of then transferring data off of your panel. And so Samsung is one of the ones who's working on these panels. And so when Elon said that, hey, we would like to theoretically be able to, potentially integrate 512 of the AI6 chips into a single training chip or training, substrate, that was the first thing that I think comes to mind, is that he is very, very likely talking about Dojo 3 being built on a panel instead of wafer, like the Dojo 1 and 2 are going to be. And that introduces, still there's major engineering challenges. So, they already talked about how hard it was going to be to manage power delivery and heat exchange on, a Dojo tile that's like this big. Now do a panel that's, probably 6 or 7 times that in total surface area. And you've got to manage all of that. But, the benefit of having more surface area is that if you can't concentrate things too, or like you don't have to have as much surface area efficiency to where you can spread things out further in order to help you with your thermal challenges, to where you're not having way too much heat concentrated in, the middle of the panel that then wants to warp and do all kinds of crazy things. So those are going to be huge challenges. But the other thing with the panel that I'm assuming that they're going to be able to do is maybe do, rows of processors next to rows of memory, so that you can keep your memory very close to your processing units, and then put those next to rows of networking, to where you're not limited to only networking at the perimeter of your panel. You can actually have something that's, you've got networking in rows in the panel, so that you've only got a block of processors and then networking, and then a block of processors and then networking. Now,
Can I jump in real quick, Hans? Sorry, I just want to make sure it's clear for my retarded brain, because we can curse now and get monetized, you guys. So one AI6 chip can go into a car or a bot, and 512 AI6 chips could be used for a panel, which could be Dojo 3.
Yeah, think of it as one super chip. Like, we're not talking about, 512 of them that are all on separate computers that are all put together in a rack.
It's all on one
We're
substrate,
talking
one
about
thing.
one giant, massive chip that then has chips on top of it. So it's like 2 layers of chips. So you've got the big one on the bottom is basically the network that connects the whole system together. And then you've got processing chips, memory chips, and networking chips all attached to that on, a giant rectangular thing that is way, way, way bigger.
And that mega chip is used for training. So it's used for, you dump the data in there. I mean, this is going to be super lame. I just want to make sure that the audience and myself are all on the same page, right? So this training one is used for a bunch of data processing. So you're basically training the computer, the AI brain, to figure out what to do with the data it's going to see when it's out in the real world. It's that training process. But then a subset of that mega chip, which is made up of, in this example, 512 AI6 chips, one subset, so one of the 512, those chips can then be put in the device that's going to take the results of that training data. And then
I think he said it's going to be 2 in the
redundant.
car and 2 in the Optimus. Yeah.
For redundancy.
Yes, exactly.
So a very small percentage of that training mega chip is then used with the same exact chip architecture. It's going to be put in the device, and then that device is going to make sense of the data it trained using that supercluster. So I guess from my perspective, the flexibility of the chip is the big takeaway here, is that they can just manufacture these chips at will, and then Tesla can decide, do they put it in the training cluster, do they put it in the bot, do they put it in the car? And that seems to be the big long-term benefit. Tell me if I'm going up the right tree.
That's a good summary. And the way to think about this is the fact that, our brains, our neurons, both learn, they both train and infer, learn and act, but it's the same neuron. It's the same substrate, the same building block that's going on. And this is something that, Larry and I have had kind of ongoing discussions about, that he's expected that in order for us to get to these higher levels of artificial general intelligence and artificial superintelligence, we're going to have to change really the architecture of the computing that we're doing and make these processing units be more, basically built on the same primitive that can do both the training and the inference, and that then you're going to want to actually change the way that you organize the algorithms themselves, so that instead of right now what we do is, you have gajillions of megabytes, petabytes of video data, and you load that up in a huge cluster, and you do this training and training and training and training and training, and then finally you finish this whole thing, and then you ship it out to the car, and then the only thing that it does once it's in the car is inference until the next time you do a batch update, and you take in some data back from inference, change your training set data, do a whole bunch of work again, and then deploy it back to the edge. That's not how our brains work. We have like a rough shot at whatever it is that we're trying to learn, and then we do one inference, and then we go back to training, and then we go back to inference and refine it again, back to training, back to inference again, over and over and over again. And so there's this much tighter loop in our learning algorithm between the training and the inference. And that is, just architecturally something that I think we're going to be moving more towards over time. And then having this computing architecture where you really do have the same, processing unit in your inference machines as you do in your training center, I think hopefully will facilitate running that tighter loop between training and inference at a higher level. So, there's sense.
There's a convergence going on at multiple different levels. Convergence with the hardware, the software, etc. And going back to what Hans was saying a few minutes ago, that you want to integrate as much of those hardware pieces on the board as you can, because it makes it more efficient, faster, etc. Like a computer, you take a typical computer, you have your chip, and then you have the memory, you have the connectivity or your network card all in different places. If you can put all that on the same board, it integrates, it makes it better, faster, cheaper. So the ultimate goal would be to have, a chip that does everything, and that's what our neurons do. They provide the connectivity, storage, processing all in one spot. Go ahead.
Yeah. So at the limit, the same footprint. So if we fast forward 10 years or 20 years, the same footprint that would be used for inference in the car could also be used for training.
I think that's the ultimate goal. I don't know how they would even do that, but I think that would be the ultimate goal years down the road.
Got it. Okay.
And I think that's what Hans was saying a moment ago as well.
Yeah.
Thank you to the sponsor of this podcast, Rebellionaire. Now, we know a lot of you are Tesla fans, and especially Tesla investors. And if you have more than $1 million of Tesla stock, Rebellionaire could be the perfect fit for you. Rebellionaire is an investment firm that helps Tesla investors reach their financial goals. They do this by helping you plan for your future, and they also institute strategies like trimming and adding, covered calls, etc. So if you're somebody who believes that Tesla has long-term potential, these kinds of strategies could maximize the number of shares you have by the time Tesla reaches those goals. And the guys at Rebellionaire do this by doing so much research on the Tesla story, and they do a lot of novel research as well. Things like doing cross-country full self-driving trips to really gauge and truly understand the capability of that specific software. They've done really novel research around the energy side of the business and other parts of the business as well. And so instead of dealing with a typical investment firm that may give you the cold shoulder by viewing your investment as too risky, the guys at Rebellionaire will help you reach your goals while fully understanding the Tesla story. And so if you're a Tesla investor and you have more than $1 million of shares, and you're interested in finding out more about Rebellionaire, I have a link for you in the description in the comment section below. You can go to rebellionaire.com/Farzad, and that's how they'll know that we sent you. And now back to the podcast.
Yeah, well, and I mean, I don't even think it's going to be that far away. You can, part of the challenge that we're facing right now is that we're, training these huge neural networks that are trillions of parameters. And if you want to retrain the whole thing every time, which is not exactly what we do, but it's close to what we do, then, there's probably 80% of the neurons that were already correct. And you're going to be retraining 100% of them from scratch just to fix the 20% of them that were wrong. And you can think about this, getting more and more narrow, or maybe it's just like this one little tiny part of the network that actually needs to be updated. If you can figure out exactly which part needs to be retrained and identify the data at one of your edge pieces of, inference/training compute that needs to update that specific part of the model, then you can actually do distributed training at the edge to where, gets into the long-term vision of FSD, where when my car, comes into my driveway and I teach it exactly where and how to park, then that, why can't I have that piece of data then be part of the larger corpus of the FSD neural network that helps everyone understand how to park better? And like in the limit, the whole FSD system should be able to learn from every specific scenario like that instantly and then feed that back into the network without it having to go through these weird cycles of, mass training and mass deployment. And I think that is something that, as this technology continues to progress, I think we'll get closer and closer to being able to do that. Like right now, we don't even really fully understand how these giant neural networks actually work, how the computation flows through them. So like we have to understand the networks themselves better in order to isolate the parts that we're going to be updating. And then once you know what you're updating, then it's easy to allocate where does that actual update happen, what size of computer is needed to make that update, and then what's the networking needs in order to feed that back to the rest of everything.
Got it.
Yeah, right now these neural networks are a black box, and I don't even know how you begin to solve that problem. It's not something I've looked deeply into, but you'd dramatically increase the efficiency if each robot, say robotaxi or a robot, like Optimus, for example, humanoid robot, if each one could learn and tweak, learn as a group, it would be insane. It'd be like if millions of humans were sharing the same brain. Imagine how quickly you can learn anything, or even, say a robotaxi doesn't do one thing well specifically, you could assign a specific robotaxi to go out and learn and improve on that specific task and add it to the greater the Borg collective, if you will. Going back to just to clarify some terms that you were using earlier, there was wafer, tile, panel, chip. So could you frame that up? Like what's delineate between those different terms?
So chips are made of wafers. Like in order to manufacture a chip, you do a whole bunch of you etch the architecture of the chip hundreds of times onto a big circular wafer. Each one of those chips is square or rectangular, and then you cut those individual chips out of the wafer. And some of the areas of the wafer, that process is not going to go perfectly, and you're going to have a wonky chip, and that one's going to get thrown out. So it's hard to have a big circular wafer that is 100% quality, that everything works as intended. And this is a challenge that a company like Cerebras, or however the heck you say that, Cerebras, they make chips that are just one big wafer, and they figured out how to deal with the fact that some of those, processing units on that giant wafer are not going to be good. And so they've got to have the error correction necessary to deal with that. But other people decided, I don't really necessarily care if, I don't have to have a one-step process where I can use this entire wafer in order to have the computation of an entire wafer all together. What if I am just taking the wafer itself and then sandwiching known good chips on top of the wafer, and then instead of the wafer itself being the processor, it's just basically that networking layer that connects every chip on the wafer to the other one. And so that's that's how the D1 tile is made. And so they go ahead and manufacture their individual Dojo
What's the D1
chips.
tile?
That is the Tesla Dojo tile. Is the first version of Tesla Dojo is the D1 tile. And so that's where they go ahead and they make the 25 chips, they test them, they make sure that each one of those chips is good, and then they put all of those chips onto a wafer that's a whole new wafer, and they're able to
they cut them out and then they put them on another wafer?
On top of another wafer. Yep.
Yeah.
and they're able to connect all those 25 chips together without having the same types of issues that they have when you're trying to make the wafer itself do all the processing. That networking the chips works a lot better at the full size of the wafer than actually processing on the whole wafer. And so that's what a D1 tile is. So we talked about chips, we talked about wafers, and that was the tile. The tile is just chips on top of a wafer, and then the circular parts that are too big get cut off the edges, and it's turned back into a square instead of being a circle. And so that's why they call it a tile instead of a wafer. Panel, I still haven't fully wrapped my head around how they get around. I'm assuming that they are like a patchwork. If you're thinking about the wafer itself being capable of doing the network communications for, all of those chips, and not having the same defect issues that you have with trying to do processing on the wafer, because you have to have really, really, really fine features in order to do the processing, whereas you don't have to get nearly as detailed with the networking as you do with the processing units. So I guess, I don't know. This is where I honestly don't know how they do a panel that is one big piece and can connect all those chips together. But
Okay.
My assumption is that it's just a bunch of square. They've taken wafers, they've cut them into squares instead of circles, and they've put them next to each other, and somehow they can manage that seam between two square pieces of wafer in a large way. And so then you're limited by the size of whatever machine does the panel instead of the machines that make the wafers.
Okay, so when you say the panel is still separate wafers that have been combined? Or
That's my
okay.
conjecture. That's what I'm saying. I'm not sure exactly how they make a panel that is. Let me
because I was wondering if they would just so with these Dojo tiles, you're taking a bunch of chips, you pattern them, you cut them out, and then you put them on a separate wafer to connect them all up. And I was thinking what you're maybe referring to with a panel was that you put everything on the original wafer. You don't cut them out. You just keep them on the same substrate. No,
yeah, those are still like the individual chips would be cut out on their own, and then they would be like you're just changing the substrate that you're putting those chips on top of. And so does
Dojo, I'd have to go back and look at the old videos on it, but is the memory on the same super chip as the as the processor and the communication? Because I know what NVIDIA's been doing is they've been putting more and more on the board over time.
I do actually need to go back and look at that. Off the top of my head, I don't think the memory was on. I think it was at the edges of
That's
the
how I
tile.
remember it. Yeah.
It wasn't like it was distributed throughout the tile.
So there's more convergence.
I think the network and the memory were at the edges. And that's fine if you own, like, you can get to be so big. Like there's a ratio between your internal area and your perimeter. And as long as your memory to processing ratio fits with your, area to perimeter ratio, then you can keep it at the perimeter. But once you get, the bigger you get, the bigger the ratio is between your area and your perimeter. And then that's when you end up having to come back and be like, okay, we need to separate this into blocks, like I was saying earlier.
Yeah. And so my thinking is ultimately what they're going to do is if it was with Dojo 1 distributed around the edge of the chip, et cetera, put all of that closer to the processor. So you have a whole bunch of those processing units with everything they need, several of them spread across this panel. And then what you can do is you can use that panel in the Dojo computer, or you can cut one out and it has everything it's need to just drop into a separate chip for the car individually. So I was wondering if maybe that's
you
what they
wouldn't
had
even have to.
So like
you
super
wouldn't even have to
modular,
cut it
basically.
out. Yes, very modular. Like the unit that you would make for the car that would have if you did want to do it that way, where if it is your processor, your memory, your networking, all of that, and you have that on its own chip, that would be, you'd just take that chip exactly like it's made, you would test it, verify that it's good, and then you would drop it on the panel substrate.
And so this is all Tesla in-house engineering, correct? This is not this. So this is where Tesla makes its money in AI is actually identifying these opportunities, going through them, and being like, okay, this is the optimal. If we're right, if we're right as we're thinking about this.
So they are working with whoever the fab is and whoever's doing the packaging. So there's like multiple layers. Making the actual silicon chip itself, that is the fabrication part, and then there's the next step is what we were talking about with Jeff yesterday, where you have to assemble that onto the packaging, a board. So that is the packaging. And TSMC has their versions of like the most exotic ways that they can put silicon together, as all of these things. They can have their memory, and that can be made in silicon and then put directly on the board along with the other stuff. And then Samsung has their ways, and the way that Samsung is doing it and the way that TSMC might be doing it, they should be similar but probably different. And so what Tesla has obviously done here is they've been working with Samsung to make AI 3 and AI 4. AI 5 is going to be made with TSMC, Dojo 1 and Dojo 2 have been made with TSMC. So they've been working with both Samsung and TSMC for years now, and they understand the limits of what both of those companies can do and the roadmap of the future technologies that they are both developing. And they have decided that, they think that they can make this AI6 chip using Samsung, even though, even if Samsung's process is a little bit more limited than TSMC's, and the supply chain benefits of going with Samsung and being right there in Texas and all that stuff outweighs maybe the most exotic things that TSMC can do. But they figured out, hey, Samsung can do this. We think this is the bet that we're making. We think that they can make these chips here on this timeline in this volume, and they can do it here in the United States with a supply chain that is independent from China. And if China decides to invade Taiwan between now and then, it's not going to tank our plans. And they can make a very significant step forward in this unification of inference compute to training compute. And Elon has said several times that Dojo 1 is meh, Dojo 2 is good, but it takes 3 generations to become great. And this Dojo 3 architecture that they have in mind, that is this combination of AI6 chips, is what he thinks, if we're basing it off of those comments, going to be the Tesla proprietary training architecture to compete with NVIDIA for training of neural networks to operate in real world embodied AI that could at least compete with, if not exceed, the capabilities of NVIDIA.
And do we want to talk about now why this convergence is important and what's relevant and what are the implications?
Definitely not. Go for it.
There's a lot of aspects to this. It's huge. So people who say that there's this, inference chips and training chips, they do make a good point where you can optimize for those specific use cases, in my view. But you also, if all of your chips are the same, it drives down your costs. It's like you want to make as many of the same type of chip or as close as possible as you can, and there's going to drive down costs that way. And my understanding with these different chips, it's not a hard limit because so much can be dealt with through software. So even if there is a difference in performance, it's not fully optimized for inference or training. There's ways you can deal with that through the software. Having a lot of memory is a power when it comes to AI. The more memory that you have, the better, and the more compute you have, the better. But the way that you program these chips and use them can maximize the utility of each one of those for like the best possible outcome. So yeah, I don't think you'd be losing that much in terms of efficiency to have a shared chip. You're going to get great efficiencies by making huge numbers of these. And I imagine it would make the programming easier to utilize both of them. If you're training on the same chip as you are using for inference, I imagine there would be some, what's the word I'm looking for? There would be benefits to that.
Mm-hmm. And let me just add one thing to that right there, Jordan. When you're training the computer, you're not making any revenue. You make revenue, you provide, you're doing useful work somewhere at inference time. And so if you have to develop super, fancy schmancy training computers that can only be used for training, so that's one scenario. If you could make a different computer that was just as good at training as computer number one, and it could do inference, you would always prefer the one that can do both training and inference over the one that can just do training, because then you can use it to learn the network that is valuable and then to do the work that you can get paid for. And so that's, I'm sure one of theoretically, the boundary conditions that Elon is exploring is like, hey, can we be as good as the best training computer with an architecture that's also equally as good at inference?
You can use these giant data centers that you use for training, and you can just kind of leave a trail of inference compute behind you. You use the most advanced data center you have to train your most advanced model, or your There might be one model or more than one model, but after you get finished use it for training and you found something better, you can then use that data center for inference. So
Wow.
And that's exactly why Jensen has, been talking about the fact that you can use A100s and H100s as inference computers after you use them to train, even though they're maybe not the best inference things out there, is because you do want to use them in a money-making capacity. You want to be able to amortize the costs of these extremely expensive computers over hopefully at least 3 years instead of 6 months. Because if you have to amortize them over just 6 months, because by the time you're done with training this specific model that you're working on today, that whole compute cluster is then obsolete. Well, that makes it pretty hard to justify your investments.
And on top of that, we have to bring into the robotaxi. And so right now, the way Tesla has, or XAI has their system set up, is they outsource the inference, I think, to maybe Oracle or something like that. So Tesla doesn't have any. When you run a query on Grok, it's not accessing an XAI data center. It's accessing somebody else's data center who's running that model. So XAI is currently just building training data centers. And in the future, what Elon wants to do is he wants to make it so all of these robotaxis can do inference compute in the cloud. So I have a feeling that Elon's going to focus the next few years on building absolutely massive training data centers for XAI, and they're going to push a lot of that inference compute out to the robotaxi fleet. So they won't need to pay a third party to host those inference operations like they do currently.
So hold on, help me understand this. So you're saying I'm not grasping the link between robotaxi and outsourcing inference, because if the go ahead.
Okay, so I understand where you're
excited.
Yeah. I'm stimulated here.
Yeah.
Okay, so currently, XAI trains one of these AI models like Grok.
Yeah.
They hand that off to a data center like Oracle, and then when you run a query, it goes to the Oracle data center.
Yeah.
What Elon wants to do with the robotaxi fleet is when it's not being used for FFD, all of those chips that are in all those vehicles become a cloud data center.
Got it.
That'll make sense.
Just like
Got it.
A Powerwall, at your house can provide power back to the grid when you're not using it. These distributed chips that are capable of doing inference can then be connected together and do distributed inference for small jobs, as long as the job itself is not too big. Or if you don't have time, like it could be a big job, but if you don't care about how long it takes to do the job, then you can afford the latency that comes with doing it on lots of little computers that are spread out and have a lot of, networking latency built into them.
So it's like a good way of thinking of cybercab at scale as an example. So when they're doing 5 million units per year or whatever, 10 million, whatever the number is, these are all actually multi-purpose units, right? They provide transportation. They're also energy storage because they have a battery, and they're also distributed inference compute, because when the car is not running, that compute is available. It will send a signal to the mothership that will say, hey, I think I have X number of seconds available for you to tap my chip to run an inference query. And then if it's not done, it will ship the package off to another car or to some server somewhere, and then they will finish the job. So it's kind of like, okay, got it.
Yep.
And it also solves the problem of power and electricity with data centers, because all these vehicles come with a battery built in. They can, So once you start looking at, go ahead.
And there's one more additional thing here. If you can buy more chips, obviously your cost per chip goes down, right? So you've got the ones that you're shipping out in the car, you've got the other ones that you're shipping out in the Optimus, you've got the ones that you need in the data center to do your training. But then what if you do like in between size that then you put next to every single mega pack at every single solar farm, and that when you have, you can think of, there's a trade-off here where do you want to store your electricity as energy, Or do you want to turn that energy into compute to do some useful work, and
Which you get paid for.
Which you get paid for, exactly. And so if you are generating way too much electricity out in the middle of nowhere, and you don't have a way to get that electricity efficiently to customers in the city, well, yeah, but you could do your inference there. And so then you could have kind of a intermediate, like a middle layer of, you've got the big things in the data centers to do training, you got the little things out at the edge doing useful work, and then you've got these middle things that's kind of interwoven into your energy layer, that those can also do training. They could do training, they could do inference, and that interconnection with your energy infrastructure, obvious. Like, this is the thing that people have been talking about with Bitcoin for so long, is like, why don't you have Bitcoin mining and, right next to your energy resources? And, this is something that a lot of people have done, if the energy resources have enough spare energy to where they can run your chips full out all the time, because like the competitive marketplace for doing Bitcoin mining is so intense that basically the only way you can stay right side up is if you can run your mining rigs full out, 24/7. And so that's hard to do if you can only use energy half the day. Well, you're obviously not going to put a Bitcoin mining rig as they exist today there. But this inference, I think there could definitely be a cost benefit trade-off that totally works, where you could 80% utilize or 50% or 60% utilize those chips, because you're just, you're going from your million chips to like 1.2 million chips. And so like, it's not that much additional expense for you to get those, 0.2 million, 200,000 extra chips made. So I don't know, like, this kind of gets out into the far future, and it is somewhat sci-fi and somewhat far-fetched and hypothetical at this point in time, but it is one of the things that I think we are going to be moving more towards. And especially over that time, like 2028, 2029, 2030 in AI terms is like an infinity away almost.
Yeah. So will those chips, sorry, Jordan, I'll throw it to you here in a second. So will those chips, does Moore's law apply to AI chips as well? Or we don't know?
Moore's law looks silly next to how fast these AI chips are evolving, because
really,
yes, Moore's law has almost died for CPUs, that it's hard to get CPUs to run any faster, more efficient. Like we're
hitting the limits of physics.
Yeah, they're getting better, but it's not as fast as it used to be. The thing about what we're doing now is, and the reason why CPUs are so hard is because there's a limit to how many parallel tracks that you can run with a CPU, and it's not that many. And that is the fundamental shift of GPUs versus CPUs, and then tensor cores and all this other stuff, is that they are way more parallel units of processing power. And so if you've got problems where you can do, 1,000,000 steps all side by side, because the next step after it isn't dependent on the result of any one of those things, then you can process a lot more data a lot more quickly. And that's what a GPU does, is, it doesn't matter, one pixel on your desktop doesn't care what the color of the pixel over one from it is. And so you can compute what is the color value of every single pixel independently of one another. And that was the fundamental problem that Jensen decided to tackle, because he wanted to explore this world of parallel computing, and graphics was just like the first use case. But he fundamentally believed that parallel computing was going to be the future of computing a long time ago. And he chose graphics And that's why these are called graphics processing units, but really they're just parallel processing units. And yeah, he chose that, like I said, because it was the great place to start building this parallel computing thing. But he's always believed that there were going to be a lot of other realms, fields, whether it's science, whether it's technology, that we're going to massively benefit from this parallelized computation instead of serialized computation. And that's why they've always invested in having these libraries that help with various verticals in science, because he was looking for, what after graphics, what are going to be the next things where we can use these parallel processing units to unleash human potential. And so first it was graphics. Then the next thing really that hit big was mining for Bitcoin. And then that kind of went away as more specialized chips came in to do that thing. And then the thing after that has obviously been AI. And there are so many different, just like we've talked about, things that end up being the bottleneck for doing this parallelized computation at any one point in time, whether it's the networking, the memory, how many processors can you put in a single place? There's just a whole bunch of different dimensions. And if you make Moore's law speed process on every single one of those dimensions, then they add up to be this thing that is so much faster than Moore's law overall. And that is what we have seen from NVIDIA, that they're, doing more computation per watt at a rate that is way in excess. If Moore's law might give you a doubling in a year and a half, in AI, you might get 100 times in a year and a half. And it's because we are, like I said, doing this parallel computing, and we're figuring out, how do we solve the memory problems? How do we solve the networking problems? How do we solve the processing problems? How do we solve the software problems to do all of that? And like every single one of these things, they all multiply together to give us that total speed improvement.
And so the takeaway here is that each unit chip of compute of either inference or training over time, very, very quickly for the next 5 to 10 years, is going to get way, 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 way smaller. And it's going to get way, 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 way better at calculations. And it's going to use way, 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 way less energy. Is that fair?
Exactly.
And they're going to integrate more on each board or set of chips. And that's important because you're going to be, for instance, the Colossus 2 data center that XAI is working on is going to have 1 million GPUs. The more that you can put on each one of these boards, the less networking it requires, the faster that these data centers can come together, and the more efficiently the whole thing will run. So it's economies of scale, basically. So and that's why these like GB200 GPUs, they use, if you include the overheads, it's something like 2 to 3 kilowatts per GPU. So they might just keep getting bigger. Who knows? But yeah, the more that they can, the larger they can make each GPU, the easier it is to build the data center, because each component of that data center is larger. So instead of like 100 GPUs, you might need 10 or 50 GPUs. So that's a lot less cabling.
Got it.
And more efficient resource-wise, because between every one of these GPUs, you need miles and miles of cable, or hundreds of miles of cable between all these GPUs. So that's a lot of copper.
The end result becomes a lot easier to achieve because of all these efficiency gains. Mm-hmm. Yeah, got it. I interrupted you before, Jordan. What did you want to?
Oh, I have like 10 things written down here that they're getting sparked off.
Pick another one.
It's just convergence on top of convergence. There's, if say you look at the cyber cab, and this is something we talk about in the Tesla community, that there's, what other company could have made the cyber cab? You need somebody that can do manufacturing. You need somebody that understands the software. You need somebody who understands the hardware. And when it comes down to this AI infrastructure that society is going to run on, there's only one company that can do all of it, and it's Tesla. Everything from the energy to the chips to the software. And it's all, it's
so like, crazy.
Yeah. It's like the cyber cab on steroids. Because, for instance, if you have...
It's like humanity's OS, basically.
Yeah. It's like these futurist images where you've seen, like, where the buildings are made out of silicon and everything's LEDs and things like that. That's very far in the future. But it gives you an idea. just from a capital efficiency perspective, for example, you have BYD that can make megapacks. You have companies that can make solar, et cetera. You have companies like NVIDIA that can make chips. But you have a robotaxi. That's going to be something that provides transport, stores energy, like you said before, and can also serve as cloud compute. The amount of capital efficiency that you have there, utilizing that resource all the time, just blows anything else away.
And just to drive home this point, right, of capital efficiency. So each cybercab is going to cost somewhere around 20 to 25,000, probably less, to make per unit. But this thing's probably going to generate at Uber prices in the medium term. It'll generate about $100,000 of revenue per year just driving around. And then on top of that, it could also generate. So when it's not driving, so the 100,000 per year, let's say it's 16 hours driving per year. The other 8 hours, or when it's doing low compute. Okay, so like where my head is going to. Sorry, let me finish this point before I jump to the next one. I think I have ADD. I'm diagnosed. So when it's not driving, the compute can also be used for inference, and then that 8 hours inference they can charge whatever. I don't know, like $10 an hour. I don't know what the number is, but they're making money, right? But then at some point, don't you think we're going to be like those same chips that Tesla's going to use for driving, and like let's say by 2030, driving by then is going to be so solved by artificial intelligence that the overhead of compute they're going to have on the chip is probably massive, right? So like if the humanoid robot runs at 100% capacity on AI 10, Cybercab only probably needs 20% or less. That other 80% then opens up for whatever, right? So and that's where there's even if the chips get way better than driving is needed, you're not going to waste money on putting that chip in the car because you're going to end up using it as cloud inference. Right? So you are super incentivized to get as many good chips as possible, as fast as possible, because that compute's not going to go to waste in a device that is going to use a small percentage of the actual total compute needed for that use case.
Yeah,
right?
Yeah. And this is something I was thinking about yesterday before this conversation was like hardware 4, it's being used in robotaxis already. It's pretty much already there. Now, they will be able to utilize more compute and make it better, safer, etc. They still have a lot of demand for more compute in these vehicles. But the deeper you look into the future, it looks closer to what you're saying, which is there's going to be this potential for having a whole lot of extra compute on that chip that's not used. And
once you reach a certain safety threshold there, like your compute needs are actually they're gonna go up and they're gonna peak, and then they're actually going to decrease. Like that peak is gonna be the first time you solve it at whatever 100x safer than a human. Once it's that safe and it can do every single thing that you want it to do and more, then you can figure out, okay, how do we actually make this code more efficient so we need less compute? And so it will, the needs on AI 5, AI 6 could actually over time shift to even more non-robotaxi network use case because you need less and less computation on that chip in order just to do your cybercab job over time.
And I wonder if at some point, after we get so many robotaxis on the road, you kind of get a swarm intelligence thing where because there's not all these idiot humans driving around bumping into each other, the roads become safer. So it's like you get this exponential effect where the more cars you get on the road, the less compute you need because there's less hazards on the roads because there's less humans on the road. And on top of that, there's probably going to get to a point where these robotaxis can communicate with each other and avoid each other and share information across the fleet.
As you were
I was
saying,
just saying I agree.
Okay.
Sorry. As you were talking, I was sending a query to Grok. I'm asking it, how much revenue does a cloud service provider generate per kilowatt of energy for inference calculations? I'm just super curious to see what the number is, because it's like, okay, so if like Cybercab is going to be making money driving people around, I'm curious, like as the compute gets better and better, like which one's more profitable, inference compute or driving?
Yeah. Well, at the moment, inference compute, I'm assuming it's negative because none of these companies are really profitable yet.
Well, Well, the revenue line for Tesla's already going to be profitable on the thing it's running.
Mm-hmm.
The inference compute is gravy, so the revenue is going to fall to the bottom line because they already have sunk costs into the car. Yeah. Sorry, go ahead.
Yeah, minus energy costs.
Right.
Yeah, and right now those energy costs are huge. That's a good point.
Oh, so that's what you're saying is that the cost of energy of inference is actually more than how much you're charging to run the compute.
I wonder, because right now it takes a huge amount of energy to run these calculations for you. So I don't know the answer to that. And this is one more reason why Elon is pushing for scale, is to drive down these costs. So not only does it make the robotaxi less expensive, it makes their life easier, it makes programming easier. The larger the scale that you can make these AI data centers, the cheaper that it gets for each one of these queries. So you want to be the biggest in the game. And that's, part of the reason why I think Elon is pushing for a terawatt of compute. Because if you make that your goal, you make your goal being the biggest, the most powerful, the fastest, you're going to be able to run these queries the cheapest. And not only that, not only having the cheapest queries, but you're also going to have the best model because of the bitter lesson.
I just can't get my head like I'm so stuck on this thought of like everything with a battery is going to have an inference computer on it.
Yeah,
it's crazy.
Everything's going to have a battery and a chip. Everything is computer. So
everything is computer.
Yeah.
Holy shit. Was that like a secret message that we got from the president?
Wow. It's as a goofy of a thing as it was to say. There's
about as accurate.
Yeah.
Yeah.
Yeah. Good ones.
Yeah, I think the other aspect of what they're doing that I think a lot of people might miss that ties into the bitter lesson comment here is that
and remind the viewers what the bitter lesson is.
Yeah, so the bitter lesson says the smartest possible thing that you can make that probably exceeds, the capability of humans requires two things. It requires a lot of compute and a lot of data. And the more, if you can, and those two things are proportional. Like you need, if you want to double the size of your compute, well, you probably need, some sort of something that is doubling of basically double the data. So double the compute, then double the data. And you need to do that over and over and over again. We've reached the point with LLMs and all of these AI systems like OpenAI is making that are things like ChatGPT. We've kind of run out of text data that these things can use. And so now they're having to figure out, okay, how do we make our own data so that we can continue to ride this curve of the bitter lesson? Because we can make bigger computers, but we don't have enough data to continue to scale to where it makes having the bigger computers worth it. So yeah, great. But then text isn't the only type of data, obviously. There's also audio data and video data. And audio data and video data obviously require a lot more data for the same informational content that text has. And so you can scale video data and audio data to much higher levels. And so if you want to just continue to make bigger and bigger computers, man, it sure would be nice if those things worked very seamlessly with audio and video training. Who does more video training than anyone in the world right now? Tesla is the obvious answer. And I mean, obviously, Google's going to be the other one. I'm sure that we've already seen, their video generation model is incredible. Probably, it's way better than OpenAI's. And the reason for that is because they're throwing more compute at it and they have more data to throw at it than OpenAI does. And so, of course, their video generation model is going to be better than OpenAI's. But Tesla also has been thinking about this problem. That's why they built Dojo 1 in the first place, is because training on video data has completely different ratios of data to processor than doing text. And now NVIDIA has been able to innovate in their GPU architecture to where they can still train video better than Dojo can, because Dojo ran into other bottlenecks. But this is the underlying first principles thinking that Elon has been approaching building Dojo systems with. And so the question is Dojo 3 going to be better than Google TPU? and whatever the best thing is from, the NVIDIA GB3000 instead of 300, or I'm sure it'll be different letters, but if Dojo 3 can be way better at video than anything else, then that means they can continue to pursue the bitter lesson. And what is it that we all care about? Like, we all care about real actions in the real world. This is what CyberCab is. This is what the Optimus Project is we want real things to go out in the real world. And when you're interacting with the real world, you're interacting with things in video and audio and text. So you need to be able to do all three of those things. And so this architecture is going to be the supreme architecture for doing real world work. And yeah, that's, this is another area of convergence where you take that and then you add it, like the best training architecture for real world AI, the best embodied platforms for real world AI in CyberCab and Optimus and other future, robotics platforms that I'm sure will also follow. On top of having your batteries, on top of having solar energy, on top of, and like these platform businesses obviously have opportunities that things that don't have the full platform don't have. I mean, this is why AWS ended up powering so much of the internet revolution, is because, there were people that made storage, there were people that made networking, there were people that did flexible amounts of compute, but no one brought them all together in one place that was easy for other people to use to build apps on top of, like AWS did. And it's that, serving of the whole suite of things that you need in order to build an application for the web that enabled AWS to just dominate the Web 2.0 revolution. And like, that's the type of platform that Tesla is building with embodied AI robots.
And so could it, is if, and some of the discussions was around like the Tesla XAI merger. I mean, so as you're talking through that, what I envision is that, Tesla could be humanity's brain in a way. Like they would do because they have so many different modalities that they can process and provide tokens for video, audio, text, with Grok, et cetera. So they're positioning themselves as one of humanity's brains that people can basically rent or use.
Not just the brain. I mean, it can be
and
that,
the action.
But the brain and the body. It's like both.
Action.
That work, useful work is a combination of brain and body, and they're doing both.
Yeah, got it. Jordan, go ahead.
Oh no, I'm just listening.
Okay.
But there's is there something you want to move on to next?
If you have one, please.
Okay. I've got all kinds of stuff.
You have a list of 10, go.
Why Samsung? And why is this, why Samsung?
That was one of my questions.
Yeah. I knew that you had this on your brain. I saw your post the other day.
Yeah.
And so I guess right now, my view is that TSMC is the belle of the ball. That's the kind of like everybody wants to work with TSMC. They're the best processes, the most cutting edge technology and things like that. But Samsung is, my understanding is they're right behind. Their process nodes might not be quite as advanced and they might not have quite the yields on their chips that TSMC does. But because of that, they're desperate for somebody to work with and they're desperate to expand. And you can't discount that desire on their part. So Elon's taking advantage of that. I said years ago that,
I agree.
I would love Tesla to get into chip manufacturing or something like that, but it's too complex. Or it's not an industry that you really want to get into. But this partnership with Samsung is the best of both worlds. Essentially, Tesla is going to form a tight junction with Samsung, and it's going to be similar to their partnership, in my view, that they have with Panasonic, where they work with Panasonic to design these battery cells, and there's a deep integration between those two parties to produce a good product at low cost. Yeah. So Elon and Tesla can kind of wag the dog with Samsung. It's as close as you can get to vertical integration without having to vertically integrate. And so they should get better deals on everything. They should be able to build more in-house, because these chips, as Jensen Huang has said, it's not just like you're just putting a chip on a board and you're finished. There's thousands upon thousands of components that go into one of these GPUs. There's the wiring, there's the connections between them, there's the case. It's just, it's a very complex piece of equipment, these AI servers. So they might be able to work with Samsung to vertically integrate as much of that as possible in-house to drive down the costs.
Yeah.
And so you have Elon dropping his special sauce in there. Like if he's going in there and working with them, he might be able to get Samsung up with TSMC in terms of chip yields and things like that. He's very good at manufacturing. And that's what, it comes down to with these chip yields. So yeah, it could elevate the performance of Samsung at a bargain basement price. And on top of that, looking deeper into the future, when XAI moves away from NVIDIA GB200s and 300s, NVIDIA is getting like a 70% margin on these GPUs that they're selling. So if Tesla can even get like, most of that, they might be able to build their data centers for half the cost that everybody else is building. So if they're building their data centers twice as fast, and if they can build them for half as much, they're going to clean house. And this is all very speculative, but this is one of the most exciting things I've seen, and things I've been most excited about for Tesla in years. It's phenomenal what could be coming down the pipeline.
Go ahead, Hans.
Well, I think that point that you made, Jordan, on XAI, like if we've proposed the possibility that Dojo 3 and AI 6 will be on par with or potentially exceeding what TPUs and NVIDIA's GPUs can do at that point in time. Of course, XAI is growing their compute clusters at insane rates. Of course, they're going to want to buy, even if it's within, remotely the same ballpark, like if it's half the performance of the NVIDIA and the TPU at that point in time, but it's 1/3 of the cost, they're going to buy tons of it. And that is like a huge, and they won't be the only ones who want to either. Other people will also want to. It's like the potential for Tesla to sell that architecture beyond, to external customers as well as themselves. Which, that does pose its own challenges. But if they wanted to, I'm sure the demand would be there.
I think just being able to dictate terms or like dictate more with Samsung than TSMC is a huge bonus for Elon and Tesla. Like having involvement, I think it's probably a big deal for them because he mentioned they are a true partner, right? But when I read Elon saying true partner, what it means is like I'm gonna have influence in what they should be doing for my product, right? So that's huge. Proximity to the Texas factory, huge. Decoupling away from China, TSMC, huge. So I think it's definitely multifaceted. Securing long-term supply, huge. But I mean, the more it's become pretty obvious that TSMC is going to be able to dictate terms way easier against Elon than Samsung would. And Samsung's, sort of quote unquote desperate situation because they just haven't been able to keep up with TSMC. That it's like the perfect leverage for the company to partner with them. They have everything aligned for them. It was just a matter of them committing to a number and then saying, okay, we're going to go all in. My question becomes like, will Tesla have to raise or take a loan out to support their long-term ambitions with chips? Because this is 16 over 10 years, was it? Or 5 years or something? I forget how big of a runway they have on the deal. But
yeah, I knew it was 16, but over multiple years, but I didn't know. That is a good question. I mean, it can't be that long.
But he said it's the beginning.
Elon obviously said it could be a lot bigger than that. So
what I'm interested in seeing is like how's Tesla going to fund that growth in chips? Because Robotaxi and Bot are going to go balls to the wall, right? And so Robotaxi, every product that Tesla's going to make in the future is going to have freaking their power walls, like you said, and their mega packs should damn well have fucking chips on them so they can start, distributing the stuff. So all that stuff's going to cost money. Are they going to have enough cash flow coming in from the business to fund these operations? They're going to have to raise debt. I don't think it matters, honestly, because the long-term potential of this thing is so huge. Like, if you're an investor, you would want them to do whatever it takes to get their hands on this stuff, because the runway they get from it is it's unbelievable. It's completely unbelievable. Yeah, I think Samsung was a great idea. I mean, I had no idea it was in the works, but great. Glad that it happened.
I wonder, AI 5 was slated to come sooner than it is. So it seems like there was some sort of a delay with TSMC to produce AI 5. And then the question is that because the process node that they want to use is behind, or the packaging node is behind, or is it just that other customers took priority? My guess is it's probably other customers taking priority and Elon getting shifted down the order stack.
Did not like that.
And yeah, like that alone would be like, well, hey, you're fucking with my ability to execute at the speed that I want to execute at. Like Elon has.
Well, I mean, I think about it too. Like AI, AI is viewed as this ultimate bomb, right? Whoever gets there first wins. So if he feels like he doesn't have control over the speed of him getting there first, of course he's going to take a different path, obviously, as anybody would.
And, because of that dynamic where Apple and NVIDIA, both of those are huge customers relative to Tesla today, and they both primarily use TSMC for all of their fab. Well, Tesla is always behind them. And yes, so TSMC might be ahead in taping out these 1.6 nanometer nodes compared to Samsung. But that doesn't mean that Tesla's going to have access to that 1.6 millimeter node before Samsung could get their first 1.6 millimeter node or nanometer node up. And so this is another, dimension here, is that because they are customer number one for this Taylor, Texas fab, then they get to have whatever comes out of that fab as soon as it is up and running. And so if Elon can say, okay, we're all in on the Taylor, Texas fab, I'm going to be riding their butt to make sure that they're getting stuff out the door as quickly as possible. And then as soon as they start getting stuff out the door, that we're getting that yield way up so that everyone here can, keep this investment in the black, that we're not, making so much scrap that everyone is underwater, then that's a huge win. Samsung also has the ability to do some of the advanced packaging stuff. So it can do not just two-dimensional chip architectures, but also 2.5D and 3D architectures where, that allows you to potentially stack memory right on top of a chip, so that you don't even have to go off through some sort of, networking layer to get to your memory. There's all kinds of interesting things that can be done here. Those things come at, like they're hard challenges when you do that, because now you've got a lot more heat in the same place. And so your thermal management challenge gets to be a lot harder when you're going to 3D architectures. But, Samsung is doing that type of work. Theirs is called X-Cube. I think TSMC's is called SOIC. But it's, the same basic overall type of architecture, and Samsung can do that. And so, yeah, if you can be customer number one for Samsung's X-Cube, and you're going to be customer number 10 for TSMC's SOIC, well, that means absolutely, like, if you have the ability to have a seat at the table to make sure that those things are working well for Samsung, you should at least try. And then if your contract is set up in such a way that if they fail to deliver, that then you have outs to go work with somebody else. Like, you don't lose anything.
Yeah. Crazy. What other stuff do you have on your list, Jordan?
That pretty much covers it. That hits the major notes that I had in mind before we met up.
Yeah. Yeah, it feels, I mean, the analogy I've used is, it's like back in 2014 when Tesla was like, oh, we're gonna build our own battery plant, you guys. We're gonna build, and then everyone's like, okay, yo, you psycho.
That battery
right?
plant is going to have the same capacity that the entire
the
rest of the world makes today.
Yeah.
By the way.
Exactly. And what's interesting about this plot line is that at that time, EV demand was very dubious, right? For the majority of people. I think for those of us that followed it closely, we're like, yeah, of course, everything's going to go electric. And the trend continues. But this AI thing, I think everyone's on the same plane. Like everyone believes. So it's like him putting his chips in and getting his own, might as well put a Tesla logo on that Taylor building. Just put a Tesla logo on it, because that's basically what it's going to be long term, right? So that is, I think the investor base and the broader public are going to take that move a lot more seriously, because the technology that surrounds that move, I think people understand just how game changing it is. Just most people use ChatGPT, that I talk to, like they know what an NLM is. And you just kind of like, you help people visualize, well, imagine that, but in a robot, or imagine that, in a self-driving car, et cetera, et cetera. I think it's much easier to explain that. So I think what the exciting thing there for me ultimately is like, this is a 10x to 20x to 100x on what the company's working towards. And it all still fulfills the original mission of moving the world towards a sustainable future, because every single thing they're going to use to put these chips in, again, has a fucking battery. And what's going to be the best way to recharge that battery long term? Solar, right? Pretty awesome.
Well, that's one thing I'm curious about is a lot of people have poo-pooed the idea of Tesla getting into solar and manufacturing solar panels again. But they were saying the same thing like 3 or 4 years ago when I did a post about Tesla needs to somehow get involved in chip manufacturing. But one thing that would be different if Tesla got into solar again would be they would have captive demand. Because if Elon truly does have plans to build 1 terawatt of compute over like the next 10 years, that's going to take all the output from all the solar panel factories that they can build for a decade or 2 decades. And if we're looking at a future society where basically we want as much energy and compute as we can possibly get, it starts to make sense at that point.
AI demand is going to lead us to fully sustainable energy.
Yep. It's like currently, like if you want electricity at a fair price, solar is the best way to go. It's the most scalable. Right now, the current administration is pushing on fossil fuels, et cetera, and that, like, just looking at that neutrally, that's the way they want to go. There would be a good argument for that if we had spare generators laying around and spare generator manufacturing capacity laying around. But we don't. All the generation capacity or the manufacturing capacity to make generation is booked out like 3 to 5 years ahead. Nuclear, it's realistically 5 to 10 years away. But if you want solar panels, you can start up a solar panel factory pretty quickly or import them at a slight premium or significant premium, depending on how the trade deals go. A premium to what you'd pay previously. But as I was talking with Iola Hughes the other day of Real Motion, despite all the tariffs that they've slapped onto batteries and a lot of the incentives they've taken away, batteries are still cheaper than they were a few years ago because they've gotten so much cheaper due to economies of scale. So I think things are going to slow down a little bit in terms of total solar demand over the next few years. But the people who really need these solar panels are going to pay for them. Data centers and things like that. And that's one good thing that the administration is doing. If they're trying to strip out as much of the permitting as they possibly can, and they're trying to say to these AI data centers or technology companies, if you guys want power, you have to build it.
Yeah.
And so...
Yeah, and as long as you don't limit them in what they have to build in order to build it, then yeah, the one that's the most scalable at a semi-reasonable price will win. And I think that's the biggest...
As long as you have a fair market.
Yeah. Well, I mean, even if it's not too disadvantaged. I think that's where the overlap is with, Tesla's mission to transition the world to a sustainable energy future. Well, that gets a lot harder to do when you decide, hey, let's like 10x our energy needs because we're also simultaneously going through this intelligence explosion that comes along with AI, but that's also an opportunity, like we've said here, because if you're saying, okay, now we need to 10x the amount of energy that we have, well, now we're going to have to re-underwrite how are we going to make 10 times more energy than we make today, and we're going to have to have to rebuild some type of infrastructure. Then, you know, you're looking at making those giant capex investments, and even if it is just these AI companies, you know, that are building giant data centers, even if they're the ones doing, you know, 50, 60, 70, 80% of whatever this new build out is, that new build out will happen with whatever technology is the most scalable, most reliable, and lowest cost. And, you know, I think right now that all of those things push towards battery and solar.
And it's worth noting that solar in the United States is already significantly disadvantaged compared to any other place in the world, and yet it's still gobbling up huge amounts of market share. Solar in the United States, and I'd have to look into exact details of why, but a post by Jigar Shah a few weeks ago, who used to be a head of, I think, loans at the Department of Energy, but he posted an image the other day where solar in the United States costs twice as much as any other place in the world. And yet it's still dominating in the United States in terms of new electricity additions. Or
no
new
wonder they had to up the incentives for everything else, because
they're trying to level the playing field.
It's a bailout.
But it's a losing battle because solar is a fundamentally better technology. So as I said, I think they're going to slow it down maybe a little bit in the next few years, but ultimately solar, I mean, we could cut half of the cost out of solar deployments in the United States pretty easily if we just, I think it has to do with permitting and regulation requirements. And if we manufactured those solar panels in the United States at massive scale, we might even be able to get our solar panels less than, for instance, Europe, and get close to the cost that China's doing it. And at that point, as Chamath Palihapitiya has said several times, the marginal cost of new power, once you get the solar cost low enough, it goes to almost zero. It just costs you nothing to expand.
Yeah. No, it's very exciting. I mean, and the exciting thing about where we are now is that that's the obvious trend that we're going towards. Too many economic forcing functions, too much demand on technologies that are obvious net positives for society from a productivity perspective that use a lot of energy, which is going to force us to be very innovative about energy. Like it feels like America has finally reached the chasm of like, oh shit, we need to do something about this. And that's usually when this country does best, is when like, oh shit, we need to do something, because we're all fucking lazy. You know, we're all just like to hang out and eat McDonald's and like watch TV, you know? But then it's like, yo, China's going to come after you. Oh shit, let's go. You know? Yeah.
And I mean, I've definitely been grateful to see the administration taking some of these things seriously. There are important things that they need to do. And like the All-In Summit this last week that is really looking into, you know, how do we win in AI? That's great. But I think
release the
honestly,
Epstein files.
The bigger thing,
not even kidding,
to push us forward towards some of this is actually, you know, I think it's more important that Google and NVIDIA and Meta and Microsoft understand that we can't just sit on our butts and let China take us over. And like those collective entities are capable of just charging forward in this arena far more than the government is, at a far faster pace. And so like our, you know, the health of our capitalist economy and these Mag 7 companies, and obviously like Tesla first and foremost among them, that is going to be the saving grace of the United States more so than policy. It is important that we get regulations cut back. And I think, to your point, Jordan, if we can, you know, this was the thing that, what was his name? The senator that held up the initial Joe Manchin. So Joe Manchin, like, he held the initial plan. What was it? That was going to be like 2 trillion or 4 trillion or whatever.
Yeah.
The thing that ended up becoming the IRA, was it the Build Back Better plan? I think was the first
Green New Deal stuff, and
Build Back Better.
Yeah, so he held that up, and they didn't end up getting to pass that because he wouldn't vote for it. And the reason that he wouldn't vote for it was because he wanted environmental protection permitting stuff to get reformed under the NEPA rules. That, you know, it could take like 7 years or 10 years, I think, even in some cases, to get new energy projects. It was mostly gas that he was concerned about because he's from West Virginia. But it was going to have an impact on both the oil and gas industry and the solar and other industries, because everything has to go through these permitting processes. So it was going to impact mining. It was going to impact solar and all kinds of things. And all of that, he was pushing very hard to get that stuff done. They were able to get him to sign on to the IRA with promises that they were going to do this stuff. They didn't actually finish. They didn't get it over the finish line. And then as soon as it got his vote on the IRA, then they reneged on all their promises to reform all of that environmental permitting, and he lost his seat and they booted him out. They're like, screw you, dude. Like, so anyways, like that's, I mean, thank you, Washington.
Politics.
But if we can, I say all that just to set up the fact that if we can cut through all of that regulatory red tape, even if it is under the guise of drill baby drill, like it is those same regulations that keep us from being able to drill baby drill, that keep us from being able to mine baby mine, and solar baby solar.
That's a good point.
Exactly. It's like we've traded. There's been this whole trade-off exercise that's happened between the last administration and this administration. I'm certainly not happy about a lot of the stuff that was in the big, beautiful bill. And, but they are doing positive things with regards to regulations, because that really adds a lot of costs and really slows things down. So it's like, but it leaves you wishing, why couldn't we have people making engineering-based decisions rather than political-based decisions? Because what we should be doing is level the playing field for all the energy technologies, stop trying to pick winners, and let the market sort it out.
Yep.
And then remove as much of the regulation as we can. That's the solution. It shouldn't be like, oh, I hate solar, I hate wind farms, or I hate coal. It shouldn't be those two things. It's just like, all right, just deregulate and make it a free market, and it'll sort itself out.
Are you a U.S. citizen, Jordan?
Yes.
Are you? How old are you?
I'm 43.
Are you running in 2028?
I hadn't planned to. I've always
I'll vote for you.
I'll
be your campaign manager.
I would love to get into politics.
Really?
Oh yeah. Oh whoa. It's like, I feel like I've been doing dry runs and training for my entire life to go into politics.
That would be awesome.
But the thing is, like, there's other things that keep me from doing it. But if those things resolve themselves, I'd love to get into it.
That would be awesome.
Like, I don't get tired of locking horns with people and arguing about these things and making an idiot of myself. And like
Jordan for president, let's fucking go.
We need Jordan for governor first. Let's show what you can do.
Let's get you to be governor of Ohio first against Vivek, and then after you win that, we'll get you in the White House. We
need a little bit more autism in public office. So.
I agree. I was going to say, like, the comment I was going to make is like, wow, I feel like one of the things that could get in the way is your autism. But I feel like if you think your autism is the strength, then holy shit, let's fucking go.
Well, it's just a little sprinkle. It's enough to...
It's enough to be dangerous.
Yeah.
You have the optimal amount of autism.
Exactly. Yeah, and sometimes it's just like you don't fully, it's kind of like Elon loses perspective on himself sometimes, and he my heart goes out to you and things like that. But that can be managed. It's just like I have to really control my diet and really get things on an even keel. And that's something we should talk about after.
That is such an autistic thing to say, is that I can control my autism with my diet.
It's true. Like, you can optimize the shit out of your body and it's like you're trying to control your brain. I understand what Elon says when it's like his mind is like a storm, And it's like, yeah, I totally get that. And I know I've gotten
The correct
better.
dose of mushrooms will fix anything.
it's yeah, I've wanted to try that too. Now we're getting into psychedelic drugs, and there's something else I was going to talk about. Yeah, after the podcast is diet optimization and things like that.
We should do a podcast about that. I think that'd be super interesting. Yeah,
I think it would be too. And one person that seems really dialed in on this stuff too is Dylan from Dylan Luminous from Electrified. Because I saw what he posted on one of his videos the other day, where he's like, he has all of his biologic indicators and things like that. I do the same thing. Like, I've been getting tested out the wazoo for the past couple of years to find out what does what. And
autism is a hell of a drug.
Brian Johnson light.
Yeah. Oh, I love, like, Brian Johnson. That's what he's doing is so,
it's very
so
cool.
Awesome. But
it's very cool. We should do like maybe we'll bring you and Dylan on, and then we'll do like a pod about health optimization. I need to get into that stuff. Like, I'm noticing, like, ever since I had Clive, my brain just doesn't work the same. Like, I require so much more effort to get it to light up to the levels it was before, and I'm just by around 3-4 o'clock my time, I am so fucking tired. Yeah. And on top of that, I'm trying to, like, exercise, and I'm trying to keep somewhat, semi-fit so I can eat things on the weekend that make me happy, and it's like, and I'm trying to keep up with sleep. It's hard. What would make a killing? A actual fitness diet regime for parents. I feel like a lot of these things are, like, optimized for people that don't have children, and they don't have, like, 1,000 things going on. It's like, you need so much time and energy to actually make the thing work. I don't know. I might be a little bitch about it, but I just feel like
cost benefit. And this is part of what's so great about what Brian Johnson's doing. It's like he's using himself as a guinea pig, because you can read all the studies you want, but as soon as you start testing, you get a realistic view of how these things are actually impacting you. But there are ways that you can, with extremely minimal effort, significantly improve, like, brain fog and things like that.
Okay.
Just like for instance, there's ways you can even out your what is it called? Your blood sugar. I forget what the technical word is, but you can even that out. Just like, for instance, if you take a little capsule of vinegar before a meal that's high in carbohydrates, it deactivates some of the enzymes in your stomach and slows down the digestion of those carbohydrates. Oh. So you don't get as much of a spike.
Like
you don't get as much of a spike. Yeah. And it's the spike and the crash that causes issues for you. So little things like that can help quite a bit.
That's good to know. Mm-hmm. That's actually good to know.
Yeah. And so we can actually start talking lingo. What's that?
Lingo. What is that? Not a sponsor, but if you want to be.
Yeah, not a sponsor, but this is a blood sugar indicator that it's like a little patch thing that you stab the back of your arm with it. And so you can track what your blood sugar is all the time. And you can see, like, hey, when I eat this breakfast, I have the spike and the crash, and you can associate it with how you feel. And so, like, if you have that, and then, try these different experiments that Jordan is talking about, you can totally figure out how to keep yourself in a nice tight, range that helps you to feel better, digest better, lose weight, all the things.
You use that?
I have used one, so it comes in a 2-pack. They're good for 2 weeks each. I started one, and that one is the second one that I haven't opened that I need to.
So you just keep it stuck to your arm for 2 weeks, and it just tracks you the whole time, and you can.
It has an app, and you can see all the things, and you can tell, like, hey, I ate meals here, I had an ice cream there, whatever, and then you can tie that to times, and then see how your blood sugar is impacted by all those different things. And, it'll track exercise, like all the stuff.
Okay.
And this stuff is critical, because it's like, there's so many people you get into middle age, and you feel like taking a nap every afternoon, like you're a hobbit.
Yeah, I'm kind of there right now.
And that's, a lot of that often has to do with just like, deficiencies, etc. But I found it's usually not a deficiency that's caused most of the issues I've had over time. It's some sort of insult to the system, something that's bugging me. If you remove all the insults to your system, you really don't have to worry about the deficiencies. It's rare that people actually have a genuine deficiency. Oftentimes when people supplement, what you're doing is you're kind of giving your body a boost to help it deal with the things that are insulting your system, things like that. So if you level out your blood sugar, that it can help a lot. And one thing that's worth noting is that 50% of the population is pre-diabetic or diabetic. And 80 or 90% of those people don't even realize it.
That's crazy. I have a blood sugar test machine at home thing, like the thing that you poke your prick and you put the thing and it gives you. That sugar is never an issue for me. I mean, I'm like my fasted sugar level is like 73 or something, 75.
Have you ever tried going into ketosis?
I've never tried going to ketosis, no.
Okay. You find out in ketosis how bad your situation is. Like, really? Right after the Tesla Owners Michigan event, I was like, all right, I'm kind of sick of feeling awful. And I found the more meat that I eat, the better I feel, because the more it evens out my blood sugar. And so I was like, I'm going to go into ketosis. So what I did is I got one of those ketone measuring kits and also the glucose measuring. And you're supposed to go into ketosis after 3 or 4 days. It's taken me 5 weeks to go into ketosis. And that's an indication that there's like glycogen nodules in your liver and your body's just kind of like pulling. Basically, my liver has become optimized to store all these extra carbohydrates.
Oh, shit.
So your body, it's like, there's all these indications that I noticed that I was starting to get a little bit pre-diabetic. I won't go into details, but you start noticing things as a man that things aren't as perky when you wake up in the morning.
Too much detail, bro. I thought you were going to make it more vague. It's so obvious.
But yeah, like, and then you go into ketosis after 6 weeks and it's like,
wow.
Rhino. So it's
so do you notice a big difference in ketosis, like your energy levels and stuff?
Oh yeah. Big difference. Everything's a lot more even. And yeah. And I've noticed a difference in when I wake up in the mornings, how things are. The blood flow.
Can you stop talking about your dick, bro? Okay.
So yeah, and that's like, as a man, that's like your first indicator that something might be a little bit off in your system. Is like, because like when you're 20, things are totally different, and like it slowly changes over time. But you're at a point, you're like, when is the last time that actually happened? And then you go on a ketosis and you remove these carbs and stuff from your diet, and it's like, oh, I feel like things have like reversed for about 10 years, and I've only been doing this for 6 weeks, and I'm not even fully into ketosis yet. What you have to look is the ratio of blood sugar to ketones, and it's called your GKI index. And my GKI index as of this morning was 5, and it's only below 6 where you're really starting to get into ketosis. And I've been between 6 and 18 for like 6 weeks now. It's just bounced all over. And this is also, and this is why I wanted to talk to you about it, because I want to make sure you guys are looking after your hearts. There's a whole bunch of different tests that you can take to check how you're doing, how your cardiovascular system is doing. And a lot of them are just BS. For instance, these calcium arterial scores that all the tech influencers are pushing at the moment, they're useful, they're helpful, but they're, for example,
I got a little bit on my carotid, but it's not enough to make any issues.
What were you going to say, Hans?
Is that the same thing that Brad Gerstner has been talking about? The calcium one?
Yeah, and I responded to him like, I was like, why are you pushing this test? It's not the best test, because it measures the amount of calcium in your arteries.
Probably invested in it.
But yeah, it could be. But here's the thing.
I think it's the one that his doctor sold him on, if I remember correctly.
And it's better than nothing, and it's pretty cheap, and it's available widespread. So from that perspective, it's good. But here's the problem. In your arteries, the first thing you want to do is limit the inflammation, because it's the inflammation that attracts all the cholesterol and all the goop to form in your arteries. Yeah. So if you can tamp down your and that's what statins help with. Statins help reduce that arterial inflammation. They don't actually fix things by reducing your cholesterol, which is the way people think they work. That's not the way they work. It keeps it keeps your arteries from being inflamed and the cholesterol sticking. Now, let's say you do start getting some of that cholesterol to stick. And then it starts becoming an issue at this point. But there's kind of two different types of plaque. There's the soft plaque, which is kind of like a pus. And if that pus kind of erupts out of the artery, it gets into your system and it forms clots. And basically, it's kind of an unstable soft plaque, and that's a real issue. Now, if you start healing your arterial system, a lot of that will kind of start to harden up and it'll stabilize. And at that point, you don't have to worry about throwing these clots anymore. But it's not good that your arteries have hardened a little bit, because that soft plaque is starting to harden up. Because it's preferable to have no.
Or you delete the risk of clots.
Exactly. And what that calcium arterial score measures is how much hardened plaque is in there. So you might be in a position where you get one of these high calcium scores, but really what that's telling you is that you had a soft plaque that's hardened up and is now stable. So it actually could be a good thing in some instances. So what you need a carotid intermedia, I forget what the last word is, but it's a CIMT test, and they're harder to find, and it's hard to find somebody who can do it well, but they're about $250. They do an ultrasound on your neck and the arteries in your neck, and they look at the amount of soft plaque and hard plaque that you have.
I see.
So it's good and relatively cheap. Now, the gold standard when it comes to viewing your arteries, what's the word for it? But basically, they pump a whole bunch of radioactive dye through your system, and they do imaging, and that's another way to check the amount of soft and hard plaque.
CAT scan? A CAT scan?
I forget what the word is. CT angiogram. That's the word I'm looking for, I think. But those, one, you're getting a big dose of radiation, and two, they cost like $5,000, $10,000, $15,000. So you get most of the benefits of that with CIMT.
Got it.
I had to drive all the way down to Lexington yesterday to get it. So that in Texas, they're probably more widely available, and there are specific companies that are more reputable. But I've improved my cholesterol figures over time, targeting the cholesterol figures that are actually indicative, because LDL isn't actually that indicative. You have to look at your arterial inflammation, and you have to look at how sticky the cholesterol is overall.
Interesting.
But that's
you've gone deep.
I've been researching it for years.
Is a super nerd.
And this is actually more up my alley than the reason I can relate to batteries is because they're biological in the way that they work. The grid is really abstract to me. Batteries, it's more for some reason I have a deep understanding of biology. So when I'm looking at my own health and solving my own problems and the issues that I've had, it's been so helpful to be able to understand biology.
Wow.
I like physics way better than biology. All that stuff, I was like, oh my gosh.
You can have physics. Like I listen to physics, it's like my brain melts. But biology, it's just it's like music to me. There's like this part intuition and part that universal structure like physics has.
Where can people find your beautiful brain, Jordan?
They can find my beautiful brain and my beautiful voice at the Limiting Factor at YouTube, and at Limiting the on X. And I'm going to be releasing a video to my paid supporters next week on Colossus 1 and Colossus 2, and it'll go public a week after that. But it's very exciting what XAI is doing. I think they're going to mop the floor with all the other AI companies. We'll see how that plays out in the next 6 months. But most of the AI companies, they want a 0.5 gigawatt data center by the end of or a gigawatt data center by the end of next year. And XAI might have it in the next 6 months. So they went from having no data centers to having the best data center in the world over the course of a few years compared to XAI and OpenAI and who's the other leading? Google, etc.
Yeah, Gemini.
And now it looks like they might be able to continue accelerating past them.
Wow.
Colossus 2, it's there's going to be, as Elon said, it's a supersonic tsunami that's coming when it comes to AI. So this Colossus 2 data center is going to be roughly about 20 times more powerful than the Colossus 1 data center.
Wow.
20 times more powerful. And that's not including all the improvements that they made to their programming, etc., because they continually improve the way that they program these AI models. They continually improve the data and its cleanliness, etc. So, like next year, I believe Elon when he says that the AI is going to get smart enough to where it can discover new physics, etc.
Wow. I feel like one of these days, like the Grok app is just going to update with this like Colossus 2 like led training run, and people are going to be like, what the hell just happened? Even just like their Imagine tab now, I got early access to their video generator. Is not very good compared to VO3, but the UI is phenomenal, and you can already kind of see that they're thinking about, okay, you say something and it just makes a video for you, and you can kind of make your own movie or show as you're going through the UI. Like that's the kind of vibe I get. And I feel like a Colossus 2 type thing, that's what it's going to be able to achieve, is like make your own movie. And Elon kind of hinted at this, make your own movie, make your own show, make your own whatever, you know?
I think
everything app.
Yeah, and I think he's got his finger on the pulse when it comes to how he's going to monetize this stuff. Like with
really?
these
AI Vine.
Yeah, AI Vines. And then also, if you look at these avatars that they've made that you interact with, like this, the next generation, this is going to be their friends. Half of their friends are going to be artificial intelligence.
Yikes.
And there's a whole lot of people out there that this really excites.
Yeah.
And that friend group of people is only going to expand. It's kind of like when I 1998, 2000, I was one of the first people that I was aware of that did online dating. Because like, did you guys ever know that app Hot or Not?
No.
Where you rate people? Okay. Well, you could also...
Funny, I met my wife on Tinder, actually.
Yeah. Well, this was probably 20 years before that.
Okay.
Because when did you meet her?
2014.
Okay, yeah, it would have been about 15, 20 years before that. Because I think I started 98, 2000, like trying to date people online. Because it's slim pickings here in rural Ohio.
Sure.
Like, how do I meet? I'll do online. And when it first started, it was great. Because you met like-minded people who are as antisocial as you were.
Yeah.
So
the sample like kind of self selects.
Yeah. At the beginning, it was very much self-selection. So you got a lot of intelligent, introverted. I'm still friends with some of the people that I met on there all those years ago. So they're still good friends of mine. But there's one website where you got on there and you rated people, like how attractive they are, and you throw up a photo. But you could also, like if you paid a little fee, you could send messages to people. So yeah, that's how I met a few people.
That's awesome. Yeah, it's going to be fascinating to watch what they're going to do there. I think every sign is pointing to like the Musk universe just absolutely dominating on so many different fronts. I think the most fascinating conversation of the second half of this decade is how the world is going to deal with the world's first multi-trillionaire.
People aren't going to like it.
I know. I agree. But it's a reality. That's where we're going. That's where we're going.
Despite how much value he creates for society and how much how much better he makes life for everybody, there's still going to be people going after him.
Yeah.
And
he's going to be the most visible, most powerful person. Yeah. There may be more powerful people or families than him, or richer than him, that people have never heard of. But because they do that by design, Elon's entire MO seems to be just, I'm going to allow myself to be as public as possible, either because he chooses to, or because he wants to, or because it's some form. Something,
I think it's because he's so autistic he can't help himself.
I think so too. And so I think that's, and he's talked about putting a target on his back, that, like it maximizes the attack vectors if, he has all these different things or whatever. But being a public figure that's going to be worth multiple trillions of dollars because of the amount of value your companies are going to create through artificial intelligence, that is inescapable. And he needs to figure out he doesn't need to figure out anything. The bigger question becomes, what does society do with that person?
You ship him to Mars.
He might self-ship himself to Mars, honestly. I think
he has a self-deportation plan in place.
Yeah. I think so. I really think Elon's. Yeah, I think that's where we're going, because Earth is not going to be happy with that. the United States sure as hell is not going to be happy with that, especially with a trend. Seems like we have this trend towards socialism and communism as sort of, yeah. I mean, the other part of it too is like, objectively, the way the United States has been operated for the last 30, 40 years, the last 20 for sure, has led to income inequality, and our schools have been overrun with teachings, anti-American teaching and anti-capitalistic teaching. That's just a fact.
Anti-enlightenment, even go back before that. It's fundamentally calls into question thinking itself.
Yes.
It's like having rational thoughts. It's like, no.
We've all been taught to memorize, not to think, right? So, and we have to memorize the thing we're being told is the truth, or it's the thing we should be considering. So I do not like that trend whatsoever. And if the richest person, or if that individual self-deports to Mars, what does that mean for Earth, right? So it's like, I don't know. Anyway, these are all conversations we need to have in the coming years, but it's coming, and it's going to happen, and we need to figure out what to do as a society. Yeah. Anyway, on that very optimistic tone, we're going to leave you here. Make sure you check out Jordan at The Limiting Factor on YouTube, Limiting the on X, and make sure you go sign up for his Patreon so y'all can get early access to his content. Jordan, thank you.
Thanks for having me.
Stick around there for me, my friend.